Hi, this is Mrs. Clark, and this is part 2 of my reflection video on reflection notes. We're going to talk about how to describe transformations and how to write the algebraic rule for reflections. So first, if I want to write the description of this reflection, if I'm pretty sure it's a reflection, I'm going to be looking for the line of reflection. So the way I do that is I see W and W prime, and I'm going to want to split them in half. So I want to make sure it's one block on one side and one square on the other side. I could also do the same with X and X prime. They're 4 apart, so I want 2 and 2. This line happens to be the y-axis, and because it's the y-axis, that's part of my description, so it's reflection over the y-axis. That simple. When I move on to number 8, this one's a little trickier because if I look here, the two shapes share this point right here, this L and L prime, so I know my line of reflection is going to go through there. I also know that J and J prime are about 6 squares apart. And so it's going to be evenly in between them as well, which is 3 and 3. So that's the same line right here. I just have to figure out what actually is this line so that I can know what to call it. So this line crosses across the y-axis. It actually hits the y-intercept of 2. And if I think about all the points that are on this line, it's 1, 2, 2, 2, 4, 2. They're all sharing this y value of 2. So this is actually the line called y equals 2. So this is a reflection across y equals 2. Now you can use the word across or you can use over. Either one of those would be acceptable in your description. Okay, looking at number 9. Again, both shapes are sharing this point right here. Also, it's splitting T evenly. So this will be our line of reflection, and that's on the x-axis, so it's just a reflection over the x-axis. But when I look at number 10, this one is different. So here I have this diamond shape almost looks like it's rotating. Because it's rotating, or because it looks like it's rotating, that's going to give us a hint that it's going to be a diagonal line for our reflection. But I can look at the W and the W prime here, and because I see that those are mirror images, I know it's not rotating. The W would have rotated all the way over here if it really was a rotation. But we'll get into that more later. So W and W prime are here, T and T prime are here, so my line of reflection goes right through there, splitting them in half. And this is that positive slope 1 over 1 that goes through the origin. It's called y equals x. This is our y equals x line, so it's just a reflection over y equals x. And that's it for describing reflections. Now we're going to look down here at finding the algebraic rule. So looking here, we want to make sure we write down the coordinates of r, s, and t, and then r prime, s prime, and t prime. We want to show what is mapping to what. And I want to actually look at the coordinates and see if I can find a pattern. So go ahead and pause the video, write these down, and then let's look at the pattern together. All right, so if I'm looking at r, I've got negative 5, 3, and I look at r prime, I have 3, negative 5. So I literally just heard the same numbers repeated, just in a different order. And I see 0, 4, and then I see 4, 0. So again, they're just swapping places. Negative 1, 0, 0, negative 1. So the way we write that is xy is going to switch and become yx, because the original x is now over here in the y spot. The original y is now up here in the x spot. X and Y are switching places. So go ahead and make those notes on your paper. This is our algebraic rule. XY maps to YX. So anytime we see that happening, this is how we're going to show that. And number 12 is a little bit different. So again, I want you to pause the video here to write down the coordinates of your TUV and T prime, U prime, and V prime. All right, so T is negative 3, 3. T prime is negative 3, negative 3. U, 2, 4. U prime, 2, negative 4. V, 0, 2. V prime, 0, negative 2. So I heard that the x's, negative 3, 2, and 0, are the same, negative 3, 2, 0. So I'm going to show that by xy mapping to x. X maps to x because it didn't change. But the y, 3, 4, 2, is going to change to negative 3, negative 4, negative 2. So y is going to become a negative y. And so this negative y doesn't necessarily just mean that it became a negative number. We're going to talk about that real quickly down here. When y maps to negative y, it means that the y coordinate changed signs. So it could be from positive to a negative like we saw up here, but it could also be from a negative to a positive, because this negative in front of the y just means that the y was multiplied by a negative 1. So if y is multiplied by negative 1, the number itself doesn't change, just the sign of the number changes. So it could change, like I said, from a positive to a negative, but if it changes from a negative to a positive, we're going to show it the same way by having y map to negative y. So go ahead and write that note down. As soon as you have that down, we're going to fold this in half just like the last one. We're going to label it on the outside, reflection notes number 2. And we're going to put it into our notebook. And as soon as you're done with that, you're going to be able to use your notes on translations and reflections to do some practice by graphing the translations and reflections, describing the translations and reflections, and then finding the algebraic rule for the translations and reflections. So do that practice, use your notes, help each other out. You got this, and thanks for watching.